Hey guys, welcome to video lesson 2.2, adding integers. This is a solution video for pages 54 and 55. So once again, just make sure you are here after you've completed the listed activities, or if you are having any kind of trouble on any one of these given questions, please don't come here just to copy work down. So let's go through this. And just a friendly reminder, if you look down in the comments in the description section on YouTube, you will find the times for each of the given problems. So if you only need one or two questions, you can go to the description and you can go to that time window of where you can find whatever number you need and just get right to that problem or two. So for number one, we're going to do 1, 2, and 3 all. We are asked to explain how we find the sum of -8 and 64/100 plus 5 and 31/100. Notice it doesn't say to find the sum. It just says explain how to find the sum. So what I like to do with students who struggle with this is tell them to go back to chapter 1. So let's pretend the numbers are just integers, -8 plus 5. And I would simply ask, would you add or subtract? Well, since my signs are different in addition, we're going to subtract. So remember, we subtract the absolute values. So 8 minus 5 is 3. And is my solution going to be positive or negative? And remember, 8 gives us a bigger absolute value, so my final solution will be -3. So what I did was, I have to subtract these two because the signs are different. And my answer is negative because the greater absolute value is a negative number. Well, congratulations, you just explained how to do number one. The process is the same. It's just the numbers are decimals now. So this is just a little more wordy. So this says because the absolute value of 8 and 46/100 is bigger than the absolute value of 5 and 31/100, we will subtract and we keep the sign negative. It's exactly what we said before. You don't have to write it this way. You can write it the way we explained down here just before. If you have questions, make sure you ask. Here's number 2. So write an addition expression using fractions that equal -1 and 1/2. So they're simply saying write a math problem, an addition problem, where the numbers that you use are fractions and your answer has to be -1 and 1/2. So we need something plus something. I'm just going to put a line in here like a fractional line. These are not negatives, that equal -1/2. So a sample answer that I have here for you is -1/4 plus -1/4. So I have two fractions. When I add, they equal -1/2. You don't need these numbers. You could have your own example as long as they're fractions and the answer results to -1/2. When you simplify, you're good. If you want to double check your example with me, that's fine. If you want to ask someone around you, you can do that as well. All right, so let's move on to number 3. So for this example, we're asked which one is different and find both answers. So one of them is different. That means the other 3 are the same. So what I like to do for this one is go through and solve them all. And there is going to be one that's going to stand out. So this one's saying add -4.5. I'm going to number these or letter them A, B, C, and D. So for A, I'm going to add -4.5 plus 3.5. So since my signs are different in addition, I'm going to subtract greater absolute minus the smaller absolute. And I get 1 since the 4 and 5/10 is a bigger absolute value and it's negative. My final answer is negative. And negative 1 is the same as negative 1.0. So either way is okay. So this is negative 1. Letter B is what is negative 4.5 increased by 3.5. So negative 4.5 increase means add. And just like before, this is going to equal negative 1. Letter C. What is the distance? Okay, this is a distance question, just like we did in chapter 1, between negative 4.5 and 3.5. So if I'm at negative 4.5, I'm going to subtract 3.5 and then take the absolute value. So negative 4.5, add the opposite. So 5 plus 5 is 10. And then 4 plus 4 is 8. Since my signs are the same, I keep negative. And remember, since we're looking at distance, we take absolute value. Solution is 8. So that's letter C. And let's take a look at letter D. Letter D says find the sum. That means add this plus this. So negative 4.5 plus 3.5. And we've done this twice before. It equals negative 1. Okay, so the solution is, which one is different? So the one that's different is, what is the distance between negative 4.5 and 3.5? And what are both answers? Well, the two answers we get are negative 1 and 8. So there's your solution. Okay, let's move on. Okay, here we're going to do numbers 5 through 11 odd. So if you notice, I only have the odd questions up here. So in my final solutions, you'll find them here on the right-hand side. So let's start with number 5. Let's see. That looks nice. So for number 5, we are adding a mixed number to a proper fraction. So we have negative 1 1/5 plus negative 3/5. So there's two things I want to call your attention to. The first thing is we're in addition. The second thing is my signs are the same. So at the end of the day, just like chapter 1, when the signs are the same, I'm going to add and keep the common sign. Okay, so I'm going to add and keep the common sign. And I know that because I'm in addition and the signs are the same. If I had one negative or one positive, I would then subtract and keep the sign of the larger absolute value. So what's awesome about number 5 is that the denominators are the same. So that's just one less thing we need to worry about. So let's make this improper. So 5 times 1 is 5, and then 5 plus 1 is 6. So I have negative 6/5 plus negative 3/5. And let's put this in parentheses. Okay, parentheses, not absolute values, two different things. So negative 6 plus negative 3 is negative 9/5. Okay, now let's make that a mixed number. Numerator or dividend goes in, denominator or divisor stays out. 5 goes into 9 one time. There's 4 left over. So the negative just comes over. 5 goes into 9 one whole time. there are 4 left over out of 5. So my final answer is -1 4/5. Okay, so there's number 5. Let's go to number 6. Okay, so let's take a look at number 7. Clean up this board here a little. Okay, for number 7, we have -9/14 plus 2/7. So when I take a look at this, you have to take these one step at a time. So in addition, are your signs the same or different? So the signs are different because I have one negative and one positive. So my signs are different. So what do you do when the signs are different? We will subtract and we will keep the sign of larger absolute. Okay, so the only thing we have extra in number 7 is that the denominators are different. So I like to start with the smaller number and start counting by 7. So 7, 14. So my common denominator is 14. So since there's a negative here, I'm just going to carry that over. This denominator didn't change, so this numerator does not change. For the next one, 7 times 2 gets me to 14. So 2 times 2 is 4. Okay, so I keep my common denominator 14, and my numerators are -9 plus 4. So denominator's 14. Now this is just like chapter 1. We're going to subtract. So what's 9 minus 4? We get 5. And who gives me a bigger absolute value, the 9 or the 4? And hopefully you are saying 9, which is negative. So my final solution is -5/14. Okay, so there's number 7. Let's move on to number 9. Okay. So just by looking at number 9 without doing anything, I know I'm going to have to subtract. And we know that why? Because the signs are different. So in addition, the signs are different. So let's begin. We have improper 15/4 plus -4 1/3. So I'm just going to write quick notes here, subtract, and then I'm going to write sign larger absolute. Okay, just quick notes. These are the 2 things I need to do, 1 and 2. So now that I know what I need to do with these numbers, I'm just going to make sure I can work with them. So I have 1 improper and 1 mixed. So let's make them both improper. So we have 15/4 plus 3 times 4 is 12 plus 1. We have -13/3. So now I need a common denominator between 3 and 4. So I'm going to count by 3s, 3, 6, 9, 12, 15. And then I'm going to count by 4, 4, 8, 12, 16. And if you notice, they both share a 12 in common. So that's my new denominator, 12. So I set up my denominators. So 4 times 3 gives me 12. So 15 times 3. And if you don't know it, come over to the side and do it. That gives me 45. And then 3 times 4 gets me to 12. So 13 times 4, I think that's 52. Yep. So we have -52. Okay, so my common denominator is 12. and my numerators are 45 plus negative 52. I know my solution will have 12 as a denominator, and up here, we decided we're going to subtract because the signs are different. So we're going to take the larger absolute value, 52, and subtract 45. So the 5 becomes a 4. This becomes a 12. 12 minus 5, hopefully you're saying 7. And 4 minus 4 is 0. So 7. Now I'm going to keep the sign of the larger absolute value. So whose absolute is bigger, the 45 or the 52? Hopefully 52 is what you're saying, so I bring its sign over. So my final solution is negative 7 over 12. So if we come over here, we get negative 7 over 12. Okay, let's move on to number 11. Let's clean up the board here. Okay, and number 11. Once again, in addition, when the signs are different, you subtract. So subtract because the signs are different. And we're going to keep the sign of larger absolute value. Okay, so that's generally what we need to do. Okay, so we're going to take these two numbers, 12 and 4800ths plus negative 10 and 636 thousandths. So just for a minute, look at these two numbers as they were integers, not decimals. This is a 12 plus negative 10. So if you were to subtract these, who is the bigger absolute value, the 12 or the negative 10? So when we subtract these decimals, we want to make sure, that the bigger absolute value is on top, which is the 12 and 4800ths, because 12 has a greater absolute value than the 10. So let's scroll down a little. I'm going to take 1248 minus 10 and 636 thousandths. Now, do you remember when we were ordering rational numbers, how we added extra zeros so all the decimals had the same amount? We're going to do the same thing here. We're going to put an extra 0 so the top decimal has 3 decimal places, just like the bottom one. I can't do 0 minus 6, so I'm going to borrow. 8 becomes 7, and this becomes 10. 10 minus 6 is 4. 7 minus 3 is 4. I can't subtract here, so I borrow, make that a 1. This becomes a 14. 14 minus 6 is 8. Decimal point goes straight down. When you add and subtract, make sure we line up these decimal points. Okay, 1 minus 0 is 1, and 1 minus 1 cancels out. So far I have a solution of 1 and 844 thousandths, and the greater absolute value is positive, so my final solution stays positive. Okay, and there is number 11 for you. Okay, let's move on to number 14. So this one, describe and correct the error in finding the sum. So I know we've talked about this before, but the easiest way to do these is for you to solve the problem on your own first. So a couple of things to notice. The signs are different. So in addition, when the signs are different, you 1, subtract, and 2, you keep the sign of, subtract, and 2, you're going to keep sign of greater absolute. Just going to initial here to abs for absolute. So what I like here is that my denominators are the same. Terrific. I don't need to worry about my signs. My common denominator is 8. I will take -5 and add 1. So since my signs are different, I really should be subtracting their absolute values. So 5 minus 1 is 4. So 4/8. So this is the original problem, which is here. This is rewriting the fraction like they did here. Now, if you notice, 5 gives me a bigger absolute value than 1. So this should be -4/8. But in here, they wrote -6/8. So they did what with the 5 and the 1? They just added, ignoring the negatives and the positives. So here's where the mistake starts. Obviously, everything else from here forward is wrong. Let's continue fixing the problem. So if I reduce 4/8, I can divide both of these by 4. And I get an answer of -1/2. So how do you describe this? Well, this student added -5 plus 1, but they should have subtracted because the signs are different. And we should get -4/8 because -5 has a greater absolute value than 1. So you could have your write-up differently than mine, but the sum of the numerators is incorrect. It should be -4/8 and not -6/8. And the final solution is -1/2. So you're describe and you're correct. Let's move on to number 15. Okay, here we're going to do 15 through 19 all. So the directions for 15, 16, and 17 say to evaluate the expression. So an expression or problems like this, they're problems where you can find the given solution. So let's start with number 15. We have x plus y. So x is a third and y is -7/4. So I'm going to replace x with 1/3 plus, in here I'm going to put y, -7/4. So just like every other question, I'm going to look in addition. I have two different signs. I have a positive and I have a negative. So my signs are different. So different signs, you subtract, and we keep the sign of the greater absolute value. Okay, so generally the directions you'll follow for this problem. And I know all of this just because in addition I have different signs. It has not changed from chapter 1. All that's changed is that these fractions, these rational numbers, we now have fractions instead of integers. It's not -2 plus 3. It's now 1/3 plus -7/4. So I first find common denominators. If we count by 3 and by 4, 3, 6, 9, 12, 15, 18, and then let's count by 4, 4, 8, 12. Oh, there we go. 12 is my common denominator. So I set up my denominators. I bring this negative down. 3 times 4 gets me to 12. What I multiply this denominator by, I multiply its numerator by the same number. So 4 times 1 is 4. 4 times 3 gets me to 12. So 7 times 3 is 21. So I keep my denominator, and my numerator is 4 plus -21. So this is what we're going to do. We're going to subtract, because my signs are different. So 21 minus 4 11 minus 4 is 7. 1 minus nothing is 1. And then the second thing we do is keep the sign of the greater absolute value. So who's greater, the 4 or the 21? So this will give us negative 17, because the absolute value of 21 is larger, over 12. That's awesome work here. So now, since this is improper, we're just going to rewrite it into mixed. 17, your numerator goes in, 12 stays out. 12 goes into 17 one time, 5 left over. So let's just close this off. So 12 goes into 17, negative one time. There's 5 left over out of 12. So final solution is negative 1 and 5 over 12. Okay, at any point you need to backtrack or look at the work or go back and listen to the explanation. Please feel free to do so. At this point, I'm going to erase 15 and go to number 16. So for number 16, we have 3 times x plus y. And you know what? Okay, here we go. 3 times x plus y. So 3 times 1 over 3. So I'm going to make this 3 over 1. And then plus negative 7 over 4. So I can cross-reduce my 3's and turn them into 1's. So this whole thing becomes 1 plus negative 7 over 4. And 1 is the same as 1 over 1 in a fraction. So between 1 and 4, my common denominator is 4. The bigger number always wins when you have 1 and another number. This guy doesn't change because the denominator never changed. 1 times 4 gives me 4, so 1 times 4 is 4. So when I take a look at my signs are different. And when my signs are different, you subtract and keep the sign of greater absolute. Okay, so first thing, okay. So my signs are different. I'm going to subtract. So my common denominator is 4. My numerators are 4 plus negative 7. So I'm going to subtract the bigger absolute value, 7 minus 4, I get 3. Keep the denominator. So that's this. Now let's figure out which sign I'm going to keep. 7 gives me a bigger absolute value, so my answer is negative. So my final solution is negative 3 over 4. There's number 16. Okay, I am now going to erase and move on to number 17. Pause if you need to backtrack or write any of this down. For number 17, we have the opposite of the value of x. I know there's no parentheses there, but I like to put them in. Plus the absolute value of y. What a great question. So the opposite, what's the opposite of positive 1/3? So negative 1/3 plus, what is the absolute value of negative 7 over 4? And we get 7 over 4 positive. Okay, so hopefully at this point we've done an example or two. We know that the common denominator is 12. We bring this negative down. So we know that 3 times 4 gets us to 12. So 1 times 4 is 4. So we have negative 4/12. And on the other side, 4 times 3 gets me to 12. So I multiply the numerator by the same number. 7 times 3 is 21. So taking a look at this problem in here, we see that the signs are different in addition. So when the signs are different, A, we subtract, and B, we keep the signs, keep the sign of a greater absolute value. Okay, so since the signs are different, I'm going to do 21 minus 4. So 21 minus 4, we get 17 over 12. And who gives me a bigger absolute value, a 4 or a 21? And the answer is 21. And if you notice, your solution is improper, so we're just going to divide it out. Numerator. Excuse me. Numerator goes in the division house, the 12 stays out. 12 goes into 17 one time. There's 5 left over. So my final solution is 1. There's 5 left over out of 12. So 1 and 5/12. Okay, I will be erasing number 17 and moving on to 18. So for number 18, your balance, your bank account balance is a negative $20.85. You deposit $15.50. So let's talk about this for a minute. You have to pay the bank $20.85 just to get to zero. So you deposit, meaning you add to this $15.50. So what we're going to do is take negative $20.85 and add $15.50 to it. So let's talk about a few things. Is my answer going to be positive or negative? Well, whose absolute value is bigger, 20 or 15? So 20 is bigger, so my answer is going to be negative. And since my signs are different, am I going to add these two or subtract them? So in addition, when the signs are different, you subtract. So I'm going to come over here and subtract these two. So 5 minus 0 is 5. 8 minus 5 is 3. I'm going to borrow. 10 minus 5 is 5, and 1 minus 1 is 0. Decimal points are lined up, and it goes straight down. And 20 has a bigger absolute value than 15, so we got our negative sign here. So we still owe $5.35 is my new balance. Okay, $5.35. I'll be moving on to number 19, so please pause if you need any part of this. So for number 19, you eat 3/10 of a pack of hot dogs. So that means if there's 10 hot dogs, you eat 3 of them. Your friend eats 1/5 of the pack of hot dogs. So if there's 5, your friend eats 1 out of 5. What fraction of the pack of hot dogs do you and your friend eat? So I want to know altogether, you and your friend had how many hot dogs? Well, you had 3 out of 10, plus your friend had 1 out of 5. But this is all out of one pack. It's not like you came with a pack of 10 and your friend came with a pack of 5. So what we need to do is find a common denominator. So counting by 5s, 5, 10, common denominator is 10. So this first fraction does not change because the denominator did not change. For the second fraction, 5 times 2 gets you to 10. So 1 times 2 is 2. So denominator is 10, numerator is 3 plus 2. So 3 plus 2 equals 5 over 10. Now we can simplify. We can divide both of these by 5, and we get 1 over 2. So what fraction of the pack of hot dogs do you and your friends eat? You guys ate half a pack of hot dogs. Okay, we are now moving on to number 20. Please pause if you need any part of this video. Okay, number 20, write all the fractions in simplest form. So in number 20, I noticed that my two fractions, or my two mixed numbers, are negatives. So I'm going to take this fraction and this mixed number and this mixed number and add them. I'm going to get an answer, and then I'll worry about the 6 after. So for number 20, we have 6 plus negative 4 3/4 plus negative 2 1/8. So what I like to do when I have a long string of problems is find the common sign. So if we go to 22 real quick, the common sign in this one is positive. So I would add the two positives first, and then I'd worry about the opposite sign later. So I'm going to take this and add them. So let's take negative 4 3/4 and add negative 2 1/8. So my denominators are different. If I count by 4, I get 4 8. So my common denominator is 8. So this numerator does not change. 4 times 2, can we see that? Yep, 4 times 2 is 8, so 3 times 2 is 6. Okay, and I know some of you are probably like, wait a minute, why didn't we make them improper first? I like to see how the numbers work out, and if I can work with them without going to improper, I just leave them. It's just one less step to worry about. So 6/8 plus 1/8 equals 7/8. And I'm adding because my signs are the same. And then 4 plus 2 is 6. And the whole thing is negative because they share a negative. So if I come back over here, I have 6 plus negative 6 7/8. Okay, I don't want you to do this, but I'm going to erase the work here just so I have some room to work with. So now I have different signs. So when the signs are different, I subtract. So I'm going to take the larger absolute value and subtract the smaller. So 7/8 minus nothing is 7/8. And 6 minus 6, well, that's 0. Now remember, when your signs are different, you subtract. Who gives you a bigger absolute value? This guy does, and it's negative. So my final solution has to be negative 7/8. Okay, I will be erasing number 20. If you need any part of it, please pause or backtrack now. And the same idea is going on for number 22. I have 10 9/10 plus negative 15 6/10 plus 2 1/10. So I'm going to look at my like signs, which are these two, 1 and 2. So since the signs are the same, I'm just going to add them. I'm going to take 10 9/10 and 2 1/10 and add. Decimal point goes straight down. So 13.0 is the same as 13. So what I have now is 13 plus negative 15 6/10. So I don't want you erasing, but I'm going to make some room here. So please don't erase your work. So when your signs are different, I'm going to subtract the bigger absolute value minus the smaller. Okay, so 15.6 minus 13.0. 6 minus 0 is 6. Decimal points go straight down. 5 minus 3 is 2. So since 15.6 is a bigger absolute than 13, my answer is negative. So negative 2.6 or 2 6/10 is my final solution. Okay, I'm going to erase the board and move on to number 23. And for this last one, it says number sense. One is the sum of two negative mixed numbers and integer. So remember, integers are numbers like -5, -8, 3, 2, 4. So the numbers we're using in chapter 2, the -4 and 3/4, or -15.6 or 10.9, those are rational numbers because they can be written as fractions. So the solution for 23 is as follows. The sum is an integer when you add up the fractions and it turns or reduces to an integer. For example, 1/2 plus 1/2. I get 2/2, which reduces to 1. So the sum of an integer is when the two fractions add up to an integer. So these fractions added up to an integer because 1's an integer. I can make these guys negative and get the same thing, -2/2 or -1. Okay, thanks for watching, and I'll see you guys next time.